Alright, draft physics science video. Holiday is returning to the subject. So again, his title is a bit irritating, but that's always the case. Problem with Inmendham's dismissal of experimental evidence. I don't think I've dismissed anything. I've accounted for it, or I have argued against it, and I think debunked it in terms of the interpretation of the experimental evidence. I'm the one pointing out that the two-slit experiment doesn't create the pattern people think it does. I'm the one who pointed out that the single slit creates a pattern that people are playing with based on how wide they make the slit. So there's lots of arguments to be made about this thing, so he's partly arguing, I think, based on past arguments I have made, and he's complaining that there's no way they can do this better measurement thing with aimed photons. And I was only arguing that they probably should be able to do it if they claim they can measure the thickness of a hair across 500,000 light years of space. Now that's what they're claiming they can do. I think if you can do that, you can aim a photon. But what do I know, right? Anyway, so look, based on my new understanding of how the electrons are creating the pattern in the two-slit experiment, the empty space, the problem is I can't be sure that there isn't diffraction in both directions, which would partially make it difficult to create an experiment that can filter light. But I could say just on the surface that the two-slit pattern is projected at a great distance, meters away. And if you look at the two-slit pattern, if a really good sharp one, you would realize that these lines here between light and dark are very sharp when you do the experiment well. And that you could imagine that you could reduce, just by moving this target, so say if this is the wall, you just move it closer and closer on a finer and finer pattern. As you make the pattern smaller, this all gets a lot tighter. These lines get more and more precise. And I'm just saying that if you say that you need a 0.5 millimeter for the slit opening, I'm saying that you would basically be able to reduce this pattern to a size where an entire, you could basically have the bright spot line up with just half the slit, and the dark place would be where the other half of the slit is. So in theory, you could aim the photons in the sense that you would know they all went through this side of the slit and none went through this side. So you could at minimum do that. All right? And that would tell you an awful lot, I think, about the experiment, in the sense if you got the same pattern, then you would know that diffraction is happening both ways, this way and this way. It's not just diffracting this way, it's also diffracting that way. So that would answer one of those questions. So I'm just saying that capacity seems well within, that's even almost within my ability to perform. If I had a little bit better equipment and a little more time to devote to it, it seems I could create a two-slit pattern on a target and then line up another slit on the two-slit pattern. I could take just one of the bars and use one of the bars as a way of regulating how the light goes through the slit and make one side dark and one side bright. I think I could do that. So anyway, that's what I mean by aiming. Ideally, it would be great if you could aim even tighter. But how tight you can go just depends on how much of this dark you can guarantee. So if I can if I can make this band bigger than 1 millimeter, which I think is quite doable, make the entire size of the band bigger than 1 millimeter, then I could basically just move it across this field until just a sliver of it was against this one slit. So it's all dark here and all bright right there. And I think that's infinitely doable. I think the distinction between light and dark is strong enough that you know that 90%, this will be 90% photons and this will be 10% in this area. So you'll have a very clear weighting anyway. And this is another issue that's not brought up at all. No one's ever where I've never seen any discussion of, is that theoretically this pattern should be almost infinite. If you were going to argue that this wave interference thing is happening, you would all have to argue that the 99-degree angle, or the whatever you want to call it, the 179.99999 degree angle, is also getting interfered with, and that angle could be traveling a mile, and there's still a photon somewhere over there, way the fuck over there. So when they do this two-slit experiment, okay, so let's just, here's the pattern. Why don't they ever take photographs? See, this wouldn't require, like the French experiment doing one photon at a time, which no one repeats either, took months. But this wouldn't take months. It could take 2 days even. Just put photographic plates over here. So just run your laser for 48 hours, create your double slit pattern, put photographic plates over here, and see if you pick up any photons. Because frankly, you should. You should pick up the pattern way the fuck over here, and way the fuck over here. So at very huge angles, you should still be able to pick up a photon. And maybe it would take a week to get the pattern way over here. It would take a week to get enough photons, but you should get them. Where's that experiment ever been done? Because by their theory, this isn't a confined pattern. By my theory, it's a confined pattern. Each one of these lines represents one of these field lines. That's what the lines represent. So when I draw 3, what I should really be drawing is something like 12 or 7 or 9, some other number of lines that are created as distances between electrons. The electrons have a standard kind of distance between each other. They hate each other a certain amount, and that's the comfortable distance they will line up on if they're free electrons. And that free electron distance is always going to be the same. And the only thing that's going to make any difference in anything is really how the lines line up based on the strength of the field. So you could theoretically put an electrical current through this thing and perhaps change some of these lines a little bit. But as you make this one tighter, you might end up making this one looser, because it's going to be always an opposite polarity. So an interesting experiment also might be, this one might be doable by me, is to create an electric field on the opposite side of both of these slits. So use metal, all right. Create a current with a gap, and a current with a gap, and make both of these highly positive. So 100 volts, 1,000 volts positive, 1,000 volts positive. Then these will automatically have to go 1,000 negative. Both of the exterior parts of the slits here, and then obviously the insides would both be 1,000 volts negative. So you'd have two opposing fields, and that might change your pattern. So, and that's something you could see quite easily just by turning the electricity on, turning the electricity off, that you'll be changing the arrangement of the electrons, presumably. Alright, anyway, but these are experiments I've never seen performed. I've never seen the two-slit done in electric fields, and I think it might be worth doing. That's all. I can't do all of this stuff. I'm just saying I'm surprised that a fundamental experiment, again, to the whole argument of the existence of this phenomenon that creates photons that can cut in half and interfere with each other, even though that's not the theory when it comes to the thickness of glass. So let's remember that when they have two glass plates separated by a distance, they're not blaming interference patterns for creating the difference in the reflectivity. Anyway, they might attempt to do something. Well, even Huygens can't account for that unless they screw with the math, and they admit they have to screw with the math. They have to put two different new constants in it. But anyway, I don't want to get off the subject too much. So again, you're taking, you're being a little, I think, excessive to say, because I said, look, if they could use AIM photons, and for me to argue that they could do the two-slit experiment in a real disciplined scientific way, like a real research lab should spend a real 6 months doing the experiment in all kinds of different ways to validate what they think the results are. This is a foundational experiment. If it wasn't a foundational experiment, then I wouldn't be making this argument, but it's a foundational phenomenon essential to this whole idea that there is this wave interference possibility, that these aren't fields, that photons aren't a field energy, that they can be interfered with, that they can be bent merely, by, well, I can't even give you a mechanism. They can be bent by some kind of magical exclusion, some sort of something, some sort of radar they send out and communicate with each other, and then decide to go somewhere as individuals. I mean, I can't even explain, because they don't have an explanation. So anyway, but yes, the current theory, okay, argues that these spaces, the empty spaces, end up going straight through. So that's the pattern forward, and the diffraction could possibly happen here when it goes in, and you'd end up with a photon going that way, or it happens here where it goes out. And that's this argument, right? So when electrons are lined up and a photon hits, it goes straight through. This electron gets accelerated, it pushes the photon out, the photon goes to the next electron, it travels through the electrons in a straight line, and it's only at the ends of the field lines where they start to traverse from that straight line. That's when this problem occurs, where the acceleration of the electron is bent by the field pulling. It's the field that decides these positions, and the field is now not allowing the electron to travel straight, so the electron travels unstraight, and therefore ejects the photon, and it can't eject it because it can't be deflected to this electron. The field's not strong enough for that, so it releases the photon into empty space, kind of a thing. But those are the angles. The angles happen at each one of these locations and are magnified by putting the target very far away. So the very far away lines up with the distance between these electrons, and that's what you get as your distance between your bands. And that there's a limited number of bands, limited to the number of field lines. So again, that's an experiment easily demonstrating that this pattern goes forever. Just put a photographic plate on the other side of the pattern and wait for some photons to show up there, because they're supposed to show up by the wave theory. That the wave theory is basically saying that this comes out of here in all these directions, and likewise over here, and that this wave will interfere with this wave, and you'll have the same interference pattern way the fuck over here. That's their theory. And I'd say it's incorrect. And I'd say that's one that can be demonstrated. So I'm just trying to point out ways that you can make this evidence stronger. And I think these are ways they should have already tested. I think, like I said, this was a battle between Einstein and Bohr. This was this huge controversy that's hugely important to understanding the mechanisms and the dynamics involved, and it just seems to me you don't want to concede that they've underdone this. You don't want to concede that they've underdone their proof of lensing. I mean, I can't say anything except I think that's just defending bad science for the sake of defending it. It's like people who defend religion. It doesn't make any sense. The Bible says something contradictory, and they'll just sit there and say, well, they just didn't, they were drinking too much when they wrote that part. Or that part was snuck in by the evil pope. They'll make some kind of excuse for why God's book has bullshit in it. Why God wasn't a better editor of his fucking Bible. Well, I'm saying that science should do better than this. Scientists should demand better than this. And I didn't have to do much picking at it to find all these holes and gaps and inconsistencies in it. And you should account for some of them. The fact that Huygens, there's no evidence whatsoever that waves function as Huygens is describing, that any wave has ever functioned that way except waves in this circumstance. Alright, anyway. So, we'll go to the videotape.
I saw a really good video. I'll attach the link in the lower box.
Yeah, it's some old guy talking at some place, so I'll listen to it. It's a lecture, so I don't mind lectures. It's not a lecture with a chalkboard, though, so...
About Proving Einstein Correct, I think it was the title.
Yeah, this Go guy.
And there are several things which I think Inmendham discounts.
Yeah, well, I mean, like I said, you keep using rhetoric that I just think is totally unfair. I don't discount. Now, you can say I've misinterpreted, I've misunderstood an argument. Maybe you can say that. I haven't fully understand their interpretation or something. You could say like that, and then you could demonstrate with some kind of quotes that demonstrate it. But I just think this is just this sounds like bullshit to me.
You need to pay attention to. But before I get into that,
like I said, I have paid attention. I've searched for all of your arguments, all of your proof. Your proof is crap. I can go over it some more if you want. I mean, if you really need me to show you some more lensing images, and I'll explain how the galaxy is 500 light years across, and that the size of the lens where this gravity is supposed to be, that would be 50 light years long. So it's a huge giant space with high gravity to make this blotch that's this long. An inch long blotch on that thing means the lens has to, the gravity has to be an inch long. You have to have hundreds of light years of strong gravity to create that brightness. You can't get that brightness without it. It has to be a strong lens through the whole pattern. Yeah, not likely, buddy.
I'll dig up some old problems that Inmendham too readily dismisses. For example, in the two-slit experiment, he repeatedly stresses that
I stress that if you could aim the photons, and that's how I've often stated it, most of the time I say, look, if you could aim them, you can get all past this stupid Heisenberg nonsense. So that's all I've stated, is that if we can aim photons, then we can sit there and if you duplicate the random pattern, and you'll know exactly where they went, you can just do it precisely and methodically, where photon A went, where photon B went, where photon C went. And you won't have a Heisenberg catch-22 anymore. There won't be any Heisenberg catches that you're measuring anything, because you've already done the measurement before you let the photons go. So, and if you want me to explain, I mean, I just think there is a way to create a filter to, in a sense, aim photons. Again, I can just go back to the small aperture argument, or the single slit argument, and I can say if you keep creating a filter ahead of the filter, so I mean if you do the diffraction pattern, and then you make another filter, okay, and then you make another filter, so you just keep making small apertures ahead of each other, technically, to some extent, your percentage of idea of a photon that is in a place where it's not going to get diffracted very much is going to be a high likelihood. Now the catch to that is that my argument with these field lines is they extend all the way through the middle. So technically, you know, this kind of closes the door to that being in the solution, because it's really not about how far away you are from the edge of the slit. It's about whether you hit a field line or you don't hit a field line. So this field line argument does kind of create the dilemma that you can't just do it based on going through the center. It's about whether you hit a field line or not. And in the two-slit experiment, it's about what side of the field line you hit. So again, it's about doing the two-slit experiment and just do this 1/4 of the two-slit experiment. So you have two slits, have the two slits to create the proper field dynamics, and then just put the light on one side. I think they can do that.
Problem could be down to aiming the photon or electron not sufficiently well through one of the slits, and that if we took care to do this, and he asserts that we can, then the essence of the two-slit problem would go away.
Well, I'm saying that it's quite obvious that to some extent you can filter. So the point is that even in the single slit experiment, you have to concede that 90% of the light, well, 85% of the light ends up in the central maxima. So most of the light goes one place. So if you can just filter out the noise on the side, you can get a finer and finer beam of light. Finer by, I mean, smaller dimensions.
This is troublesome for the quantum physicist because...
Well, again, I don't think it is. So you're saying that they don't have a laser beam that can create a dot of light, okay? That would be, say, you know, I want to use the right kind of terminology, right? That would be 1/10 of a millimeter round. So you're saying they can't make a laser beam that creates a dot of light at 10 feet, let's say, that's just 1/10 of a millimeter around. I'm saying I think they probably can. I think they probably have a laser that can do that.
Part of his prediction is that you cannot aim. So no quantum physicist...
No, you can. You just can't aim to the precision of the slits. But I'm just saying that that's the argument, though, is that the slit precision is... the photon's ability to be aimed is finer than the width of the maximum slit that'll produce the pattern. So if the maximum slit that produces the pattern is a millimeter, you know, you've got good chance, okay, of creating something, a beam of light that's much smaller than a millimeter.
He's going to waste his life trying to aim photons and electrons so accurately when he believes in a theory which says you cannot aim them.
Well, regardless, like I said, you're saying you cannot aim them, and that would just be silly to say. Headlights aim light in a direction, okay? So, yes, individual photons, probably not in the ballpark, but a group of 100 photons or 1,000 or 10 million or whatever you want to cut it down to, that's in the ballpark, and that's all I'm asking for. I'm just saying just create some kind of beam that's smaller than a 1 millimeter laser.
It would be for the people who think they can aim them to prove that they can aim them. And
well, and again, I would just argue that I don't know if people, if they can measure the thickness of a hair on a black hole 500 light years away, then if they claim they can do these fantastic measurements, I don't know how they're doing them without using the smallest quanta in the universe to do the measuring.
That, to most physicists, would be a high end to nothing because, you know, all of the experimental confirmation of quantum mechanics.
Well, again, I'm going to argue that the experimental confirmation doesn't exist, that they haven't done the experiments to pieces. They haven't done them even in any kind of, with much imagination at all. They seem to just want to duplicate it in the crudest and simplest manner possible, and just to verify their theory. They never seem to want to do anything that might produce results that would make the theory questionable. It seems obvious to me. You got some evidence of some other truth, then show it to me. But every single experiment I can find, it seems they're only trying to validate, not trying to find a hole in it.
So it is kind of, you know, proposition number one in regards of the two-slit experiment is you cannot accurately aim.
Well, again, you're saying these are propositions. You're saying these are axioms that are unchallengeable. I'm saying my whole challenge of the two-slit experiment is challenging the evidence that supports that theory. I'm saying that theory is bullshit. Okay? I'm saying Heisenberg is nonsense. This doesn't have anything to do with measuring a photon or any of that crap. It just has to do with the fact that we have no way of manipulating photons in any kind of, we have to do it by manipulating electrons, and so it makes it very difficult for us to control that experiment because electrons are fundamentally difficult to control. So I'm just saying that's our only real way to do it. The only way we can aim photons is to be able to shoot electrons in a very straight line, and that's hard to do.
An electron to go through a particular slit. To do so is to measure it. And when you do that, you get one...
Yeah, well, again, the point is that, so what? You've measured it, but if you know exactly where it's going to end up, look, I can turn the laser on and off, on and off, on and off, and all the light will stay in that band. It's not going to jump into the dark space. So we know that we have a band of light that's going to be 95% photon, and that this space next to it's going to be 2% or 3% photon. So we know we have a heavily weighted line between those light and dark spaces, and we can use that line, okay, and again, if we have one straight line, we can create another straight line and another straight line, and I would think theoretically you could just do the two-slit experiment now tangentially, perpendicular to the first time. So do the experiment this way first, then to do a filter that has it upside down to make it even narrower, a little box of light, and then a little narrower box of light, and a little narrower box of light. But that seems doable.
Statistical distribution rather than the...
Well, again, the statistical distribution doesn't have anything to do with light and dark divergences, differences. Doesn't have anything to do with 90% of the light going in the central maxima. Doesn't have anything to do with that. And theoretically, again, by their own theory, the dark spaces are 100% dark. They're supposed to be complete destructive interference.
So it's the very essence of the two-slit experiment is that we don't know which one it can go through. It actually has to have the opportunity to, or the
yeah, that's exactly my point, though. Exactly. So we can prove that wrong if we can in some way change the balance of the experiment and fudge with that randomness. And so take out some of that randomness and then see what the hell happens with the experiment when it's no longer relying on randomness. And see if it all of a sudden fails. If now the pattern completely goes away because you changed the randomness.
The randomness of the ability to go through both in a kind of general principled way.
Well, I mean, the idea of a general principle that relies on some sort of notion that the photons aren't, in a very real way, going through real positions between these two slits, you know, that's your theory. That it doesn't matter. That this is somehow that every single photon, no matter whether it was going here or whether it was going here, no matter where it was going, it turns into some sort of probability nonsense that's bigger than the slit itself, and gets diffracted in whatever, who knows what way. I mean, that's your contribution, and I don't find that realistic.
No. So just ignoring this is just not.
Again, I haven't ignored it at all. I just think it's just such a bullshit argument. I've explained why I think it would be really cool if they could do it. I haven't said, they definitely can, and they're just cheating us, and they're blah, blah, blah. Did I say anything like that? No. I'm not ignoring any of this crap. I'm saying if I can demonstrate that there's some other explanation for the two-slit experiment, then your Heisenberg doesn't have any meaning anymore. You don't have any evidence of your Heisenberg anymore. It goes away because I explained that the photon actually goes somewhere, it actually hits something, and it gets diffracted. So my point is, if I can prove it's diffraction, okay, all of your mush goes away.
Incredible. Now, he's talked recently about the idea of photons and electrons interacting with the surface electrons such that they...
free electrons.
Come off at angles. Now, what Inmendham hasn't done is given really adequate reason. I think he's tried, but he's not given adequate reason to why we get particular trajectories which are seemingly almost ruled out.
I demonstrate that I'm just saying. I'm saying you're saying there's an infinite pattern. Okay, by your theory, there's an infinitely spread out pattern that theoretically a photon goes 179.999999999999999999999 degree angle, okay, and is heading out towards Pluto somewhere. All right, your theory creates an infinite pattern. You can't even show me the, like, again, put photographic plates and demonstrate to me how the pattern does extend infinitely. Go ahead, show me it.
The dark bands from a mechanism like that.
Well, I have explained the dark bands. The dark bands are obviously the lack of existence of a angular trajectory. So these, let's just say each field line creates the same angle, okay, of whatever. Let's say it was 27 degrees. We'll just make up a number, 27 degrees. They have a separation in terms of where they are located when they have that deflection at 27 degrees. And quite obviously over a distance, through divergence, that 27 degrees is going to mean, whatever, 3 inches at 10 meters. Okay, 27 degrees is going to add up to 3 inches at 10 meters. So there's your explanation.
That's it. That's the two quantum things. Now, I'll just briefly show some of the slides. This video covers a lot of what most lay physics enthusiasts probably know about.
Yeah, I don't know if I want to change the subjects, but we'll see where he's going with this, and then we'll play along if he's staying somewhat consistent. But I don't want to mix two slit and lensing, so I'll make a separate video if he's going on to lensing or something.
Out the idea of images showing Einstein's lensing, and the fact that GPS system.
Oh, again, I've already done the GPS thing. I've already explained what is causing GPS, and it's the velocity and the fact that we're in a heavier gravity and are being bounced, and we're traveling more distance because we're in a higher Alise environment. And the further away you go, the bigger the Alising gets, which means you travel less distance. So in fact, you could be going the same calculated speed, but your metabolism, your matter, is actually going very different speeds.
Systems, global positioning systems, have to do a calculation offset to gain accuracy because of Einstein's theory of general relativity.
Well, both theories affect the clock speed, but whatever.
But Inmendham often puts it that...
I mean, one's stronger than the other, so there's one influence making the clocks go faster and another influence making the clocks go slower. But the ironic technicality is that we're the ones who have the slower clocks.
The lensing around the sun has never been done again. But in this video he cites two instances, one which is poor and one which is generally acknowledged to be a good result.
Well, what does that even mean? So one is poor and one is generally acknowledged to be a good result, which means the original experiment, which is generally acknowledged to be a good result. It took 2 years, and basically the process of the 2 years was basically having an argument about which plates we're going to throw out. Yeah, what evidence we're going to throw out because we don't like it. It doesn't fit. So you tell me, that's a great experiment, huh? Yeah, well, let's build the entire edifice, the entire building of physics on that evidence. Not too good.
But more than that, it's done with planets and stars, and I'll probably come to it maybe another instance where they're using gravitational lensing.
I bet you it won't be. I bet you it'll be diffraction. But anyway, go ahead. Yeah, I'd like to see it. Let me see the evidence of planets lensing. Because first off, Einstein didn't think that was possible. But go ahead. Let's see it.
To confirm Einstein's theory. Also, he talks about why don't they use the Hubble telescope to replicate the results. Well, in fact, he asserts that we have used not the Hubble telescope, but a telescope in space to confirm, again, gravitational lensing around the sun.
Right, so you're going to tell me he says so, and okay, well, that decides it. He says so. So unless you got a link to the Wikipedia page showing me the fucking experiment, or some web page showing me the fucking experiment, or showing me somewhere where it says that actually happened, I'm saying you're just talking blowing in the wind bullshit.
So there's lots of source taglines and things to research in this video.
Well, good luck. I'm just saying good luck finding it, because I've looked for it and I haven't been able to find it. So good luck is all I'm going to say. Good luck finding it.
That Inmendham wants to be so dismissive of Einstein's model.
No, of course I'm dismissive of the model, because the model doesn't have anything to do with explaining gravity. It just takes it off the table. It makes a make-believe dimension to shove the energy into and pretend it doesn't have anything to do with the real world anymore. So that's kind of just bullshit. Incredible bullshit. The most powerful force in the universe, and they keep pretending it doesn't do anything. It doesn't move planets. It doesn't do shit. Yeah, it does a lot of shit. And they took it right out of they took it out of physics and put it into fucking goddamn Tinkerbell theory. And that pisses me off. But beyond that, what I'm saying is your evidence for it, your evidence for Einstein's, look, this was a relativity argument. I don't want to argue relativity, but that's what was really being proven by the fucking lensing. Okay, because Einstein was making the argument that the light is staying in the gravity twice as long. That was his stupid relativity nonsense, that, because the light's in the gravity twice as long, there's enough time for it to get bent enough for us to see the bending. Alright, that's the fucking argument. And I'm just saying the evidence demonstrating that is weak. That's what I'm saying. You shouldn't be making bold claims about the fundamental function of the universe based on fucking weak evidence. That's my argument. The evidence is weak. Weak, 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 not strong. That's my fundamental argument. But yes, the theory itself sounds like religion. It sounds like made up crap. Bent fucking space. Sounds stupid.
Of the universe, where we think of it as almost a substance, which is deformable and stretchable and warpable, space-time.
Yes, by magical rules that we make up that have nothing to do with any other force in the universe. Only this one force behaves in this silly fucking way.
As a thing, as a model, I'm kind of with Inmendham that I don't think it is. It's just the model works, right? But the point is Einstein bluffly dismisses the actual existence of experimental results.
Again, that's a lie. I don't deny the existence of the experimental results. I'm saying the results suck as proof of anything. They don't get past their own margins of error. They're incomprehensibly in conflict with basic physics, like the galaxy argument, that you're in the gravity longer this way on a galaxy than this way on a galaxy. These are fundamental, factual, practical. This is physics, fuckhead. They're disobeying physics with their stupid fucking arguments. Their arguments are stupid. Galaxies aren't spheres, for fuck's sake. They're flat. Their gravity is going to be based on that flatness.
So here's more experimental results for him to research and account for.
Well, again, I don't have to account for bad evidence, okay? So, again, I'm asking you to account for the poor quality of the evidence that you're defending this with. I'm saying you account for it, because it doesn't make any fucking sense. You account for the fact that the two-slit experiment has 2 patterns in it. Where is the 2 patterns in the math? Show me the math that describes both the patterns.
In a more thorough manner than just blithely asserting over them that they're wrong and they're not in fact being done.
Well, again, I'm not asserting, thithead. Okay, what I've done is shown what they claim to be their evidence. I can't do any more than that, can I? Is there something else I can do? You have shit for evidence and you want me to somehow... Well, you're not rolling out the good evidence and showing the good evidence and debunking it. Because I can't find the good evidence, shithead. Show it to me. Link me to your fucking decisive evidence. It doesn't fucking exist.
Which again is the problem. You can, with the quantum theory, Inmendham may well have spent many hours studying lay physics interpretations of the two-slit experiment, but until he actually, and I appreciate this is difficult, but until you actually get the exact specifications of a particular two-slit experiment which has been done and replicate it and show that the results were wrong.
Well, again, that's not my argument. I'm not saying the results are wrong. I'm saying their interpretation is wrong. Where the fuck did I say the results are wrong, you dumb fucking lying cunt? Will you quit doing this shit? I've never said their results are wrong. I'm saying when they're interpreting it and saying, the photon split in half and it did this and it did that and then it went to France and then it flew back here and then it went to Japan for a holiday and blah, 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 blah. I'm saying that crap is crap. You fuck. I mean, you're such a lying bastard. I have never said their results are wrong. I don't need to duplicate their fucking goddamn experiments. I'm saying the experiment is perfectly valid. Where did I say the experiment was invalid? What I said was their math doesn't add up to their fucking results. What I said was is when even fucking lecturers at MIT, they do the math for 3 damn bands. They don't dare go where all of a sudden it gets funky and where you have 3 bands that go completely dark. They don't go there with their math. Why don't they do that? Because their math won't predict that. That's why. Fucker. I hate this fucking bullshit you keep putting words in my mouth that I never fucking said. Alright, I'm running out of time, so it's a good time to break. Thank you very much.